flexible cord listed for use with specific appliances is considered protected by the overcurrent device of the branch circuit. For a 10 ampere, 3-conductor flexible cord to be considered protected, the overcurrent device should be 15 amps. This relates to the National Electrical Code, or NEC, which provides guidelines for the safe installation of electrical wiring and equipment. Overcurrent protection is a crucial safety measure designed to prevent fires and equipment damage resulting from excessive current flow. This excessive current flow can be caused by short circuits, ground faults, or overloads. Overcurrent protection devices, such as circuit breakers and fuses, are designed to interrupt the flow of current when it exceeds a predetermined level. The NEC specifies the maximum overcurrent protection for various types of conductors, including flexible cords, based on their ampacity. Ampacity refers to the current carrying capacity of a conductor, which is determined by its size, insulation type, and temperature rating. The NEC contains tables that list the ampacity of different types of conductors under various conditions. When selecting an overcurrent protection device for a flexible cord, it's important to consider the cord's ampacity and the type of appliance it will be used with. Some appliances, such as those with motors, may have higher inrush currents when they are first turned on. This inrush current can briefly exceed the cord's ampacity, but it is usually not a problem if the overcurrent protection device is sized appropriately. For a 10 ampere flexible cord, a 15 amp overcurrent device is typically considered adequate protection because the next standard size overcurrent device is permitted. However, it's important to consult the NEC and the appliance manufacturer's instructions to ensure that the correct overcurrent protection device is selected. The NEC provides specific rules for the overcurrent protection of flexible cords in Article 240. These rules take into account the size of the cord, the type of appliance it is used with, and the operating conditions. When installing flexible cords, it's important to follow all applicable NEC requirements to ensure a safe and reliable electrical installation. This includes using the correct size cord for the application, properly terminating the cord, and providing adequate overcurrent protection. In addition to the NEC, local electrical codes may also apply. It's important to check with the local authorities to determine the specific requirements in a given area. Understanding the principles of overcurrent protection and following the NEC guidelines are essential for ensuring the safety of electrical systems and preventing electrical hazards. Selecting the correct overcurrent protection device for flexible cords is a critical aspect of electrical safety. The ampacity of a conductor is crucial in determining the appropriate overcurrent protection. Factors such as conductor size, insulation type, and temperature rating influence a conductor's ability to safely carry current. The NEC provides tables that specify ampacities for various conductors under different conditions. These tables are essential for selecting the correct size conductor and overcurrent protection device for a given application. In addition to ampacity, the type of appliance connected to a flexible cord also plays a role in determining the appropriate overcurrent protection. Appliances with motors, for example, often draw a higher inrush current when they are initially turned on. This inrush current can briefly exceed the conductor's ampacity, so it's important to select an overcurrent protection device that can handle the inrush without tripping unnecessarily. The NEC addresses the overcurrent protection of flexible cords in Article 240. This article provides specific rules for selecting overcurrent protection devices based on the cord's ampacity and the type of appliance it serves. These rules are designed to ensure that flexible cords are adequately protected against overcurrent conditions. When working with flexible cords, it's essential to follow all applicable NEC requirements and local electrical codes. This includes using the correct size cord for the application, properly terminating the cord, and providing adequate overcurrent protection. Proper installation and maintenance are also crucial for ensuring the long-term safety and reliability of flexible cord connections. Overcurrent protection is a fundamental aspect of electrical safety, and it's important to understand the principles involved. By following the NEC guidelines and using appropriate overcurrent protection devices, you can help prevent electrical fires and equipment damage. A 15 amp overcurrent device is typically considered adequate protection for a 10 ampere flexible cord. This is because the next standard size overcurrent device is permitted according to the NEC. The National Electrical Code serves as a comprehensive guide for safe electrical installations, covering various aspects from wiring methods to overcurrent protection. The overcurrent protection devices, such as circuit breakers and fuses, are designed to interrupt the flow of current when it exceeds a predetermined level. This level is determined by the device's ampacity rating. The ampacity of a conductor, including flexible cords, is a critical factor in determining the appropriate overcurrent protection. Ampacity is defined as the current carrying capacity of a conductor, which is influenced by its size, insulation type, and temperature rating. The NEC provides tables that list the ampacity of different types of conductors under various conditions. When selecting an overcurrent protection device for a flexible cord, it is essential to consider the cord's ampacity and the specific requirements of the appliance it serves. Some appliances, particularly those with motors, may draw a higher inrush current upon startup. This inrush current can briefly exceed the cord's ampacity, but the overcurrent protection device should be able to accommodate it without tripping unnecessarily. Article 240 of the NEC provides specific guidelines for the overcurrent protection of flexible cords. These guidelines take into account the cord size, the type of appliance, and the operating conditions. Adhering to these guidelines is crucial for ensuring a safe and reliable electrical installation. In addition to the NEC, local electrical codes may also apply, and it's important to consult with local authorities to determine specific requirements. Understanding overcurrent protection principles and complying with the NEC are fundamental to electrical safety. Selecting the appropriate overcurrent protection device for flexible cords is a critical aspect of this safety. The NEC permits the use of the next higher standard overcurrent device in certain situations where the conductor ampacity does not correspond exactly to a standard breaker size. This allowance is often applied to flexible cords, allowing a 15 amp breaker to protect a 10 ampere cord. However, it's important to ensure that the appliance connected to the cord does not draw more than 12 amperes continuously, as this could overload the cord over time. Flexible cords are often used to connect portable appliances to a branch circuit. These cords are subject to more wear and tear than permanently installed wiring, so it's important to inspect them regularly for damage. Any damaged flexible cord should be replaced immediately to prevent electrical hazards. Overcurrent protection devices are essential for preventing fires and equipment damage caused by excessive current flow. These devices work by interrupting the circuit when the current exceeds a predetermined level. Circuit breakers are resettable devices that trip when an overcurrent condition occurs. Fuses are one-time devices that melt and break the circuit when an overcurrent condition occurs. Both circuit breakers and fuses are effective overcurrent protection devices, but they have different characteristics that make them suitable for different applications. The NEC requires that overcurrent protection devices be readily accessible and properly labeled. This ensures that they can be easily located and operated in the event of an overcurrent condition. Regular inspection and testing of overcurrent protection devices are essential for ensuring their proper operation. This includes checking the breakers for signs of damage and testing their tripping function. Faulty overcurrent protection devices should be replaced immediately to prevent electrical hazards. Proper overcurrent protection is a critical component of electrical safety. By following the NEC guidelines and using appropriate overcurrent protection devices, you can help prevent electrical fires and equipment damage. Understanding the function and limitations of flexible cords is essential for safe electrical practices. Flexible cords are designed for specific applications, such as connecting portable appliances. They are not intended for use as permanent wiring or for running through walls or ceilings. Using flexible cords in inappropriate applications can create electrical hazards. Flexible cords are typically made of stranded copper conductors insulated with a flexible material such as rubber or plastic. The size of the conductors in a flexible cord determines its ampacity. The NEC specifies the allowable ampacity for different sizes of flexible cords. When selecting a flexible cord, it's important to choose one that is rated for the voltage and current requirements of the appliance it will be used with. The cord should also be long enough to reach the outlet without being stretched or strained. Flexible cords should be protected from physical damage. Avoid running them under rugs or furniture, where they can be pinched or crushed. Also, avoid exposing them to excessive heat or moisture. Regularly inspect flexible cords for damage. Look for cracks, cuts, or frayed insulation. Replace any damaged cords immediately. When unplugging an appliance, always grasp the plug firmly and pull it straight out of the outlet. Never pull on the cord, as this can damage the cord or the outlet. Avoid overloading flexible cords. Do not plug too many appliances into a single cord, as this can cause the cord to overheat and create a fire hazard. Use power strips with built-in overcurrent protection to prevent overloading circuits. When using extension cords, choose one that is rated for the amperage of the appliance you are using. Using an undersized extension cord can cause it to overheat and create a fire hazard. Always unplug extension cords when they are not in use. This will prevent them from being accidentally overloaded. Follow the manufacturer's instructions when using flexible cords and extension cords. These instructions will provide important safety information. Proper use and maintenance of flexible cords are essential for preventing electrical hazards. By following these guidelines, you can help ensure a safe and reliable electrical system. Remember to consult the NEC and local electrical codes for specific requirements in your area. Safe electrical practices are essential for protecting yourself and your property from electrical hazards. The NEC provides comprehensive guidelines for safe electrical installations, covering various aspects from wiring methods to overcurrent protection. The NEC is updated every 3 years to reflect new technologies and best practices. It is important to stay up to date on the latest NEC requirements. Local electrical codes may also apply in addition to the NEC. These codes may be more restrictive than the NEC in some cases. It is important to check with local authorities to determine the specific requirements in your area. When working with electricity, always follow safe work practices. Wear appropriate personal protective equipment, such as safety glasses and gloves. Energize circuits before working on them whenever possible. If you are not comfortable working with electricity, hire a qualified electrician. Electrical work can be dangerous, and it is important to take precautions to protect yourself. Proper grounding is essential for electrical safety. Grounding provides a path for fault current to flow back to the source, tripping the overcurrent protection device. This prevents electrical shock hazards. All electrical equipment should be properly grounded. Grounding conductors should be properly sized and installed. Regular inspection and testing of grounding systems are essential for ensuring their proper operation. Surge protection is another important aspect of electrical safety. Surges are transient overvoltages that can damage electronic equipment. Surge protection devices, such as surge suppressors, protect equipment from surges. Surge protection devices should be installed at the service entrance and at individual equipment locations. Regular inspection and testing of surge protection devices are essential for ensuring their proper operation. Electrical safety is a shared responsibility. By following safe electrical practices and complying with the NEC and local electrical codes, you can help protect yourself and others from electrical hazards.